Once, at the very edge of the solar system, there was a ninth planet. It was small. It was cold. It was far away from almost everything we knew. And yet, for generations, Pluto had a place in our minds that felt much larger than its size. If you grew up learning the solar system in school, you may remember the old order: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. It was always the last one, the tiny world at the end of the line, the final name in the classroom diagram, the little dot sitting beyond the great blue orbit of Neptune, close to the darkness where the familiar solar system seemed to fade away. There was something strangely comforting about Pluto being there. It made the solar system feel complete. The inner rocky planets had their warmth and sunlight. The giant planets had their storms, rings, and moons. And then, far beyond them all, Pluto waited quietly in the cold. It was not bright like Venus. It was not huge like Jupiter. It did not have the golden rings of Saturn or the blue glow of Neptune, but it had something else. It had mystery. For most of human history, Pluto was not a world we could truly see. It was a faint point of light, moving slowly against the background stars. Even through powerful telescopes, it remained blurry, distant, and secretive. It was less like a place and more like a promise, a small sign that the solar system did not end where our eyes became tired. And maybe that is why people loved it. Pluto was the underdog of the planets, the distant one, the forgotten one, the strange little world that somehow made it into the family portrait. In drawings, it often appeared as a tiny gray or brown sphere sitting at the edge of a neat row of planets. It looked harmless, almost lonely, and perhaps because it was so far away, people imagined it with a kind of tenderness. Pluto was not powerful. It was not dominant. It did not command the solar system. It simply existed, quietly, in the deep cold, taking nearly 2.5 centuries to make just one journey around the Sun. 1 year on Pluto lasts about 248 Earth years. That means Pluto has not even completed a single full orbit since it was discovered in 1930. Think about that for a moment. A world can be found, named, loved, questioned, reclassified, and debated by generations of humans, before it has even finished one trip around the Sun. There is something humbling in that. Here on Earth, our lives move quickly. Days pass, seasons change, cities grow, children become adults, new maps are printed, new discoveries are made. But out there, in the dim outer reaches of the solar system, Pluto continues its slow path through space. It is not concerned with our calendars. It does not know that we once called it the ninth planet. It does not know that we later changed our minds. It simply keeps moving, quietly, patiently, in the dark. Then, in 2006, something happened that many people still remember with surprising emotion. Pluto was reclassified. The ninth planet was no longer officially considered a major planet. It was given a new title, dwarf planet. Nothing physical happened to Pluto that day. It did not shrink. It did not leave its orbit. It did not fall out of the solar system. The mountains of ice, the frozen plains, the thin atmosphere, and the distant sunlight remained exactly where they were. Pluto itself was unchanged. Only the human label changed. And yet, for many people, it felt like something had been taken away. The solar system, once so familiar with 9 planets, suddenly had 8. The final dot at the edge of the classroom chart was moved into a different category. Some accepted the change as science doing what science does, becoming more precise. Others felt a quiet sadness, as if a childhood friend had been removed from the family. It is strange how attached we can become to a word, planet. A simple word, but one filled with meaning. To call something a planet is to give it a certain dignity, a certain importance, a place among the great worlds that circle the sun. When Pluto lost that title, The scientific reason was technical, but the emotional reaction was deeply human. Because Pluto was never only a point in a textbook. It was a symbol of the edge, the last stop before the unknown, the tiny world that reminded us that even the coldest, farthest places could still belong. And that is why the question has never completely gone away. Should Pluto be a planet again? At first, the question sounds simple, almost playful. It feels like something you might ask because you miss the old solar system, the one with 9 planets. But the deeper we look, the more complicated it becomes. Because this question is not only about Pluto. It is about what we mean when we call something a world. It is about whether a planet is defined by its size, its orbit, its neighborhood, its history, or its nature. It is about whether a small, icy body, far from the warmth of the sun, can still be important enough to change the way we understand the solar system. And perhaps most of all, it is about how science grows, not by keeping every old idea forever, but by asking better questions. By looking again, by admitting that the universe is often stranger, softer, messier, and more beautiful than the categories we create for it. Tonight, we are going to travel slowly toward Pluto. We will not rush. We will leave the bright inner solar system behind. We will pass the orbit of Mars, the realm of the asteroids, the giant worlds, the rings of Saturn, the blue distance of Uranus and Neptune. We will drift farther and farther from the warmth of Earth until the sun becomes only a brilliant star behind us. And there, near the edge of the known planetary system, we will find Pluto, not as a simple dot, not as a mistake, not as a rejected planet, but as a real place, a frozen world with a heart-shaped plain, a world with mountains made of water ice, a world with nitrogen glaciers, reddish-dark regions shaped by ancient chemistry, a thin atmosphere that expands and fades with the seasons, and a giant companion named Charon that hangs in its sky like a silent witness. Before we decide whether Pluto deserves to be a planet again, we first have to understand what Pluto truly is. And to do that, we have to begin with the strange power of a name. Because when Pluto was called a planet, it became part of a story. When Pluto was reclassified, that story changed. But Pluto itself never disappeared. It is still out there tonight, moving through the darkness beyond Neptune, carrying its frozen heart around the distant sun. There are very few objects in space that people argue about the way they argue about Pluto. Most distant worlds do not become cultural memories. Most icy bodies beyond Neptune do not appear on t-shirts, school posters, coffee mugs, cartoons, and internet jokes. Most objects billions of miles away do not make people feel protective. But Pluto does. Even now, many years after its reclassification, the debate has never fully gone silent. Every so often, it returns. A headline appears. A scientist comments. A child writes a letter. A teacher mentions the old 9-planet model. Someone online says, half joking and half serious, that Pluto was robbed. And beneath all the humor, there is something real. People still care. That alone makes Pluto unusual. In science, names and categories are supposed to help us understand reality. They are tools. They help us sort the universe into patterns. Stars, planets, moons, asteroids, comets, galaxies, nebulae. But sometimes a name becomes more than a tool. Sometimes it becomes part of how we feel about a place. For many people, Pluto was not simply the 9th planet. It was the little planet, the faraway planet, the strange one at the edge. It occupied a special corner of the imagination because it was so unlike the others. Mercury was scorched by the sun. Venus was wrapped in clouds. Earth was home. Mars was red and dusty. Jupiter was enormous. Saturn was elegant. Uranus and Neptune were blue, distant giants. And then there was Pluto, small enough to seem fragile, distant enough to seem mysterious, cold enough to feel almost impossible. It was easy to imagine Pluto as lonely. Of course, planets are not lonely in any human sense. They do not think, they do not feel, they do not wait for us. But human beings are storytellers. We look at the sky, and we turn points of light into meaning. We name constellations. We see hunters, bears, swans, rivers, dragons, and gods in patterns of stars. We send spacecraft into the dark and give them names like Voyager, Pioneer, and New Horizons. So perhaps it is not surprising that Pluto became more than a distant object. It became a character. A small, quiet character in the story of the solar system. And when its title changed, the story felt different. But why did the debate return again and again? Why not simply accept the new classification and move on? Part of the reason is that Pluto sits at the intersection of emotion and science. It is a world that many people loved before they truly knew it. Then, after it was reclassified, we finally saw it up close. And what we found made the story even more complicated. Because Pluto did not look simple. It did not look boring. It did not look like a frozen leftover at the edge of space. It looked like a world. A world with contrast. A world with shape. A world with movement written across its surface. A world with bright plains and dark regions, mountains and valleys, an atmosphere, seasons, and a large companion locked beside it. The timing was almost poetic. First, humanity changed Pluto's title. Then, less than a decade later, humanity arrived and discovered that the little world was far more complex than anyone had imagined. That is one reason Pluto still matters. It reminds us that our labels often come before our understanding. We named it, classified it, argued about it, and debated its place in the solar system long before we had ever truly seen its face. And when we finally did see it, it surprised us. There is another reason Pluto matters. It marks a boundary. Not a hard boundary, because space rarely gives us clean edges, but a psychological one. For a long time, Pluto felt like the end of the solar system. Beyond it was only darkness, distance, and the unknown. Of course, today we know that this is not true. Pluto is not the end. It is part of the Kuiper Belt, a vast region beyond Neptune filled with icy bodies, ancient remnants, and perhaps many more strange worlds waiting in the cold. But emotionally, Pluto still feels like a gate. It stands between the familiar solar system and the deep outer frontier. On one side are the planets most people know, the worlds of school models and backyard telescopes, the planets that have filled science books for generations. On the other side is a wider, colder, less familiar realm. A place of dwarf planets, frozen objects, tilted orbits, and mysteries we have barely begun to understand. Pluto is not the final world. It is the first hint that the solar system is much larger, stranger, and more crowded than we once believed. And that is why the question of Pluto's status is not just about one object, it is about the map itself. If Pluto is a planet, then our solar system may be richer and more crowded than the classic 9-planet picture. If Pluto is not a planet, then we have to accept that some worlds can be fascinating, round, geologically complex, and emotionally meaningful, while still belonging to another category. Either way, Pluto changes the way we think. It teaches us that the solar system is not a simple row of objects. It is a layered, living archive of history. There are planets that cleared their paths, moons that may hide oceans, asteroids that preserve ancient rock, comets that carry frozen memories from the early solar system, and far beyond Neptune, small icy worlds that may hold secrets from the time when the planets were still forming. Pluto matters because it forces us to slow down, to look again, to ask whether importance is the same thing as size, to wonder whether a world must dominate its orbit to deserve our attention. And maybe that is why people keep returning to it. Not because they refuse to accept science, but because Pluto touches something deeper than a definition. It reminds us that discovery is not only about finding new things. Sometimes it is about realizing that something we thought we already understood was stranger than we knew. So before we ask whether Pluto should be a planet again, we need to understand the rule that changed everything. The rule that took Pluto out of the old family portrait. The rule that turned 9 planets into 8. And the rule that still stands between Pluto and its former name. For most of history, the word planet was not as precise as it sounds today. It came from an ancient idea, long before telescopes, long before spacecraft, long before anyone knew that Earth was one world among many. People looked up at the night sky and noticed something unusual. Most stars held their places. They rose and set with the turning of the sky, but their patterns remained steady. The constellations kept their shapes, but a few lights wandered. Night after night, week after week, they drifted against the background stars. They did not stay fixed in the same celestial patterns. They moved. The ancient Greeks called them wanderers, planets. At first, that word did not mean what it means now. It did not mean a round world orbiting a star. It simply meant a moving light in the sky. Mercury, Venus, Mars, Jupiter, and Saturn were planets because they wandered. The Sun and the Moon were sometimes placed in similar categories because they too moved through the heavens. The universe seemed smaller then. The planets were not distant worlds with landscapes and weather. They were lights, sacred lights, mysterious lights, moving signs in a sky that humans were only beginning to understand. Then the telescope changed everything. The Moon became a place with mountains and craters. Jupiter became a giant with moons of its own. Saturn revealed its rings. Venus showed phases. Mars showed markings. Uranus was discovered. Neptune was predicted and then found. And slowly, the solar system grew from a pattern of lights into a family of worlds. Each discovery forced people to redraw the map. And each time the map changed, the word planet stretched a little further. When Pluto was discovered in 1930, it seemed natural to give it the same title. Astronomers had been searching for something beyond Neptune. A distant object was found. It moved around the Sun. It occupied the outer edge of the known solar system. So Pluto became the 9th planet. For decades, that answer felt settled. But science is rarely settled forever. The problem was not that Pluto changed. The problem was that our knowledge around Pluto changed. As telescopes improved, astronomers began finding more and more objects beyond Neptune. These were not ordinary asteroids from the inner solar system. They were icy bodies, living in the far cold, in a vast region now known as the Kuiper Belt. At first they seemed like distant curiosities. Then some of them turned out to be surprisingly large. There was Quaoar, there was Sedna, there was Makemake, there was Haumea, and then there was Eris. Eris was especially important because, at first, it appeared that it might be larger than Pluto. It was also far beyond Neptune. It was icy. It was distant. It moved around the Sun. If Pluto was a planet, then what was Eris? Was it the 10th planet? And if Eris was the 10th, what about the others? How many planets could the solar system have? 10? 12? 20? 50? The old picture was beginning to crack. Not because Pluto had become less interesting, but because it was no longer alone. It was part of a much larger population of frozen worlds. Pluto was not the final lonely planet at the edge of the solar system. It was one member of a distant family. And this raised a question that astronomers could not avoid forever. What exactly is a planet? In 2006, the International Astronomical Union, often called the IAU, created a formal definition for planets in our solar system. The goal was to bring order to a growing and confusing map. According to this definition, a planet has to meet three main requirements. First, it must orbit the Sun. Pluto does this. Slowly, distantly, and on an orbit more stretched and tilted than the orbits of the major planets, but still, Pluto travels around the Sun. Second, it must have enough mass for its own gravity to pull it into a nearly round shape. Pluto does this too. It is not just an irregular chunk of ice. It is large enough for gravity to shape it into a sphere. In this sense, Pluto behaves like a real world. It has a global surface, a structure, a shape, and a presence. But the third requirement changed everything. A planet must have cleared the neighborhood around its orbit. This phrase can sound strange at first. It does not mean that a planet has removed every tiny rock, every grain of dust, or every small object nearby. Earth still has near-Earth asteroids. Jupiter shares its orbit with Trojan asteroids. Space is never perfectly clean. But the idea is that a major planet must gravitationally dominate its region. Over time, it becomes the main body in its orbital zone. It gathers, scatters, captures, or controls much of the material near its path. Earth dominates Earth's orbit. Jupiter dominates Jupiter's orbit. Neptune dominates Neptune's orbit. Pluto does not dominate its neighborhood in the same way. Pluto lives among many other icy objects in the Kuiper Belt. Its orbit overlaps with a crowded outer region filled with bodies that share similar histories and similar distances from the Sun. Pluto is large and important within that region, but it has not cleared it. It has not become the gravitational ruler of its orbital zone. And so, under the new definition, Pluto failed the third test. It was no longer classified as a major planet. It became a dwarf planet. That phrase can sound smaller than it should. Dwarf planet. It almost feels like a demotion, and in a technical sense it was. But the term does not mean Pluto is unimportant. It does not mean Pluto is ordinary. It does not mean Pluto is a mistake. A dwarf planet is still a world. It is still round. It still orbits the Sun. It can still have geology, atmosphere, seasons, moons, and mystery. But it belongs to a different category. The reclassification was not simply an attack on Pluto. It was an attempt to describe a more complicated solar system. The old model, with 9 neat planets and then empty space beyond, had become too simple. Astronomers had opened a door beyond Neptune and found not emptiness, but a vast frozen frontier. Pluto had not been erased from the solar system. It had been placed into a new context, and yet the emotional reaction was powerful. Because people were not reacting only to a scientific definition, they were reacting to a change in the story they had been told. For decades, the solar system had ended with Pluto. It was the final name, the last planet, the little world at the edge. Then suddenly, the edge moved. The map became wider. The old ending was no longer the ending. In a way, Pluto's reclassification was not just about losing a planet. It was about discovering that the solar system was bigger than the version many people had grown up with. That is the strange beauty of this story. The same rule that removed Pluto from the list of major planets also revealed a richer universe around it. If Pluto had remained the unquestioned 9th planet, perhaps many people would still imagine it as a lonely object at the end of everything. But because of the debate, we now see Pluto differently. We see it as part of the Kuiper Belt, part of a distant population, part of a frontier full of ancient icy bodies that may preserve memories from the birth of the solar system. So the rule did change the solar system. Not physically, but in our minds. It turned a simple row of planets into something more complex, more layered, more mysterious. And maybe that is why Pluto's story is still so powerful. It sits right at the place where definition meets wonder, where the need for scientific clarity meets the human desire for meaning. A rule can tell us what Pluto is called, It can explain why Pluto is no longer counted among the 8 major planets. It can separate planets from dwarf planets and dwarf planets from smaller bodies. But a rule cannot fully tell us what Pluto is. To understand that, we have to go farther. We have to leave the warmth of Earth behind. We have to travel across the solar system, past the familiar planets, past the giant worlds, past Neptune's blue orbit, and into the dim region where sunlight becomes faint and slow. Because somewhere out there, beyond the old edge of the map, Pluto is still waiting. To understand Pluto, we have to make the journey. Not with speed, not with urgency, but slowly, as if we are drifting through the dark in a quiet spacecraft, leaving behind everything familiar one layer at a time. Imagine Earth below us. Blue, bright, and alive. Clouds curl over the oceans. Sunlight glows along the thin edge of the atmosphere. Cities shimmer faintly on the night side, like golden dust scattered across continents. From here, Earth does not look divided. It does not look noisy. It does not look restless. It looks whole. A soft blue world, wrapped in air. This is the world from which we name everything else. From Earth, we decide what is near and what is far, what is large and what is small, what is ordinary and what is strange. We look outward from this blue planet and draw maps across the darkness. But the farther we travel, the more those maps begin to feel small. The moon is the first to fall behind us. At first, it seems close, familiar, a pale companion that has watched over Earth for as long as humans have looked up at the night sky. But as we move away, the moon becomes smaller. Earth and moon begin to appear together, a double light in the black, one blue, one gray, one alive with weather and oceans, one silent and cratered. For a moment, it is easy to understand why worlds can become companions. Earth and the moon travel together around the sun, bound by gravity, history, and time. Later, when we reach Pluto, we will see another kind of partnership. Stranger, more distant, more still. But for now, the moon is our first reminder that no world exists completely alone. Soon, the inner solar system opens around us. We pass the orbit of Mars, the red planet, dry and cold, carrying the memory of rivers that may have once crossed its surface. Mars is a world of dust storms, volcanoes, canyons, and old questions. It is close enough to feel almost reachable, and yet still alien enough to remind us that even our nearest neighbors are full of mystery. Beyond Mars lies the asteroid belt. Not a crowded field of tumbling rocks like in movies, but a vast region of space where small bodies drift quietly around the sun. Some are no larger than mountains, some are broken fragments, some are ancient leftovers from the early solar system, pieces that never gathered into a planet. And hidden among them is Ceres. Ceres was once called a planet too, then it was reclassified. Then, much later, it became known as a dwarf planet. In that small detail, we can already feel an echo of Pluto's story. The names change, the categories shift, but the worlds remain. Ceres did not vanish when its label changed. Pluto did not vanish either. The solar system is full of these quiet corrections. We keep learning. We keep renaming. We keep redrawing the map. Farther out, Jupiter appears. Not as a small point now, but as a giant. A world so massive that it seems less like a planet and more like a system of its own. Bands of clouds wrap around it. Storms wider than Earth turn slowly in its atmosphere. Its gravity shapes the paths of comets and asteroids. Its moons form a miniature kingdom: Io, Europa, Ganymede, Callisto. Europa may hide an ocean beneath its ice. Ganymede is larger than Mercury. Io burns with volcanoes. Callisto carries an ancient surface scarred by time. Around Jupiter, the word planet feels powerful. Jupiter dominates its neighborhood. It bends the space around it with enormous gravity. It is the kind of world that makes the IAU's third rule feel understandable. A major planet is not only round, it is not only in orbit around the Sun, it commands a region. Pluto will not feel like Jupiter, and that is part of the problem. But it is also part of Pluto's beauty. We move on. Saturn rises ahead, golden and quiet, surrounded by rings so delicate they look almost unreal. From far away, the rings appear smooth, like a single thin halo, but they are made of countless pieces of ice and rock, each one following its own path, each one part of a larger pattern. Saturn reminds us that beauty in the solar system often comes from structure. A ring is not one thing. It is many things moving together. A planet is not just a ball. It is a history, a system, a relationship between gravity, time, and material. Beyond Saturn, sunlight weakens. The sun is still bright, but it no longer fills space with the same warmth. The inner solar system feels far behind us now. Earth is no longer a place we can see with the naked eye. It is only a point somewhere closer to the sun, carrying every ocean, every forest, every human story inside a speck of light. We pass Uranus, tilted strangely on its side, rolling around the sun like a pale blue-green mystery. Its seasons are extreme, its atmosphere is cold. Its history may include a violent, ancient impact that knocked it into its unusual tilt. Then Neptune appears, deep blue, windy, remote. Neptune is the last of the 8 major planets. It is a world of supersonic winds and dark storms, a giant wrapped in methane blue haze. It orbits so far from the sun that one year there lasts about 165 Earth years. For many people, Neptune is now the final planet, the last official member of the major planetary family. But it is not the end. This is where the old classroom map begins to fail. Because beyond Neptune, space does not become empty. It becomes less familiar. We enter the realm of the Kuiper Belt, a cold, distant region filled with icy bodies, dwarf planets, fragments, and ancient remnants. Here, the sun is no longer a warm presence. It is a bright star, powerful but remote. Its light still reaches this place, but with only a tiny fraction of the strength it has on Earth. Out here, sunlight does not feel like morning. It feels like memory. The distances become difficult to hold in the mind. On Earth, we measure our days by sunrise and sunset. We measure our lives by years. But in the outer solar system, time stretches. Orbits take centuries. Seasons unfold over generations. A human lifetime becomes a brief flicker compared to the slow movement of these frozen worlds. And somewhere in this dim frontier, Pluto is moving. Not at the edge of existence, not outside the solar system, but in a region we are only beginning to understand. From far away, Pluto does not announce itself. It does not shine like Venus. It does not glow with rings like Saturn. It does not dominate space like Jupiter. It is small, quiet, easy to miss. A faint world in a vast, dark sea. And yet, as we approach, the old idea of Pluto begins to fall away. It is not just the last dot on a school chart. It is not just the object that lost its title. It is not just a frozen leftover. It is a place. A real place, with landscapes waiting in the dark. For decades, we could only imagine those landscapes. We could calculate Pluto's orbit. We could estimate its size. We could detect its moon. We could guess at its composition. But we had never truly seen it. Not clearly. Not closely. Not as a world. Then a spacecraft left Earth and began one of the loneliest journeys in the history of exploration. It traveled for more than 9 years, across billions of miles, past the giant planets. toward a point of light so distant that even radio signals would take hours to cross the space between Pluto and Earth. And when it finally arrived, humanity saw something no one had expected. The little world at the edge of the solar system had a face, and on that face was a heart. For most of the 20th century, Pluto was not a landscape. It was not a horizon. It was not a place where you could imagine standing beneath a black sky, looking across frozen plains toward distant mountains. For most of that time, Pluto was only a point of light. A faint, patient dot moving slowly through the darkness beyond Neptune. Astronomers knew it was there. They could follow its orbit. They could measure its brightness. They could discover that it had a large moon. They could estimate its size and mass. But the surface itself remained hidden. Pluto kept its face turned away from human eyes, not by choice, but by distance. It was simply too far. Even the best telescopes could not show it the way we could see Mars, Jupiter, or Saturn. There were no clear craters to study, no sharp mountains, no obvious plains, no weather systems drifting across its surface. A leftover from the early solar system, a small, icy world too far from the sun to be active, too cold to be complex, too dim to be surprising. But the universe has a way of hiding its most beautiful details behind distance. To truly know Pluto, humanity had to go there. Not with astronauts, not with a crew, but with a small spacecraft carrying cameras, instruments, and the hopes of everyone who had ever wondered what the ninth planet might really look like. That spacecraft was New Horizons. It launched from Earth in January of 2006, the very same year Pluto would lose its official title as the ninth planet. There is something almost poetic about that timing. As human beings were preparing to change Pluto's name, a spacecraft was already beginning the long journey to reveal Pluto's nature. New Horizons left Earth at tremendous speed, but even then, the journey was immense. The solar system is larger than our instincts can easily understand. On a map, the planets are often drawn close together so that we can see them all at once. But in reality, the spaces between them are vast oceans of darkness. New Horizons had to cross those oceans. It passed beyond the orbit of Mars, beyond the asteroid belt, beyond Jupiter, where it received a gravitational boost that helped carry it faster toward the outer solar system. Then it continued into the deep cold, year after year, moving farther from the sun, farther from Earth, farther from the warm center of the planetary system. For most of its journey, Pluto was still only a target ahead, a distant point, a promise. Back on Earth, people waited. Scientists planned. Engineers listened for signals. The spacecraft traveled silently through a region no human being had ever crossed in person, carrying within it the first close look at a world we had known by name for more than 70 years, but had never truly seen. And then, in July of 2015, New Horizons arrived. It did not stop at Pluto. It was moving too fast to enter orbit. Instead, it performed a flyby, racing past the dwarf planet and its moons at astonishing speed, collecting as much data as it could during a brief, historic encounter. For a few hours, after decades of waiting, Pluto was no longer far away. It filled the frame, and when the images began to return, the world held its breath, because Pluto was not what many people expected. It was not plain. It was not featureless. It was not a dead, frozen ball. It was astonishing. There were bright regions and dark regions, smooth plains and rugged terrain, mountains rising from ice, strange patterns across the surface, a thin atmosphere glowing faintly around the edge, and most unforgettable of all, there was a vast, bright shape that looked, from a distance, like a heart on Pluto. The little world that had just lost its place among the major planets appeared to be carrying a heart across the darkness. Of course, The heart was not truly a symbol. It was geology. It was ice. It was light, reflecting from a vast region on Pluto's surface. But human beings cannot help but see meaning in shapes. And after all the arguments, all the sadness, all the jokes about Pluto being demoted, that image felt almost impossible. The world we had reclassified looked back at us with a heart. For many people, that was the moment Pluto became real. Not just a name, not just a debate, not just a small body beyond Neptune. A world. A place with a face. The data did not arrive all at once. Pluto was so far away that sending information back to Earth was painfully slow. The spacecraft had gathered an enormous amount of data during its brief flyby, but the signal crossing billions of miles of space was faint. It took many months for the full treasure to come home. Image by image, Pluto revealed itself. A frozen plain here, a mountain range there, a dark red region shaped by chemistry, a blue haze in the thin atmosphere, a moon, Charon, scarred and strange beside it. Each new piece changed the picture. It was like assembling a puzzle sent from the edge of the sun's light. And with every piece, Pluto became harder to dismiss. The first surprise was how young parts of its surface looked. In many places across the solar system, old surfaces are covered in craters. Every impact leaves a mark. Over time, if nothing erases those marks, a world becomes heavily cratered, like the moon. But some regions on Pluto appeared surprisingly smooth, almost fresh. That suggested something had been renewing the surface. Something had changed it. Something had moved. And movement was the last thing many people expected on a world so small, so cold, and so far from the sun. Then came the mountains. Not mountains of rock like the Rockies or the Himalayas, but mountains likely made of water ice. On Earth, water ice is fragile compared with stone. It melts, cracks, floats, and flows. But on Pluto, where temperatures are unimaginably cold, water ice can become hard enough to behave like bedrock. So Pluto has mountains made of frozen water. Imagine that. A landscape where ice is stone, where the familiar materials of Earth have been transformed by distance from the sun. Nitrogen, which on Earth makes up most of the air we breathe, lies frozen across Pluto's surface. Methane, a gas on our world, becomes frost and ice. Carbon monoxide freezes too. The chemistry of an atmosphere becomes the geology of a landscape. Pluto is a place where the ordinary becomes alien. The New Horizons images showed that this small world was not static. Its surface seemed to be shaped by slow processes: glacial movement, sublimation, deposition, freezing, and perhaps even deeper internal activity. These are not fast changes, not changes like rivers flowing after rain or clouds racing across an earthly sky. On Pluto, change happens in a slower language. A language of centuries, of seasons longer than human lives, of ice creeping almost imperceptibly across plains under a dim and distant sun. And above this surface, Pluto has an atmosphere, thin, fragile, temporary in some ways, but real. As Pluto moves closer to or farther from the sun during its long orbit, its frozen surface materials can sublimate into gas or freeze back down again. The atmosphere may expand and contract with the seasons, like a faint breath in the cold. This is not an atmosphere like Earth's. You could not breathe it. It would not warm you. It would not soften the silence. But its existence matters. It means Pluto is not merely a frozen sphere. It exchanges material between surface and sky. It has weather, in the broad and alien sense of the word. It has cycles. It has change. And the more we learned, the more the original question became complicated. Should Pluto be a planet again? The New Horizons mission did not change the official definition. It did not give Pluto enough gravity to clear its orbit. It did not move Pluto out of the Kuiper Belt. It did not rewrite the rule that had been created in 2006. But it changed something else. It changed how Pluto felt. Before New Horizons, the argument about Pluto could seem like a technical debate over words. Planet, dwarf planet, Kuiper Belt object, classification, definition. After New Horizons, the debate had images. And images have power. It is one thing to say that Pluto is small. It is another thing to see its mountains. It is one thing to say that Pluto is icy. It is another thing to see its bright plains stretching across a heart-shaped basin. It is one thing to say that Pluto is far away. It is another thing to realize that, even in that distance, even in that cold, the world is not still. The flyby revealed that Pluto was not a simple leftover from the solar system's formation. It was a complex place with its own story, its own landscapes, its own atmosphere, its own relationship with its moons, its own mysteries waiting beneath the ice. And perhaps this is why the Pluto debate refuses to die. Because the more we learn about Pluto, the less it feels like an object that belongs at the edge of our attention. It feels like a world that asks to be understood. Not loudly, not dramatically, but quietly, the way distant things often do. New Horizons did not settle the argument. In some ways, it deepened it. Because now, when we ask whether Pluto should be a planet again, we are not asking about a blur. We are asking about a place with a heart. A place with mountains. A place with frozen plains that may slowly move. A place with a thin blue haze around its horizon. A place that waited in the dark for billions of years before a small spacecraft from Earth finally came close enough to see it. And once we saw Pluto clearly, one thought became difficult to ignore. Maybe this little world was never less interesting than the planets. Maybe we had simply never been close enough to know it. The heart of Pluto is not truly a heart. It does not beat. It does not feel. It does not love, remember, or mourn. And yet, when humanity first saw it, almost everyone understood why people called it that. Across the surface of Pluto, a vast bright region stretches like a pale heart pressed into the frozen world. It is one of the most recognizable shapes ever seen on another body in the solar system. Not because it was designed to be beautiful, but because our minds are built to find meaning in the unexpected. And on Pluto, of all places, the symbol felt perfect. A distant world, a demoted world, a world many people had quietly defended. And there, on its face, was something that looked like a heart. The official name for this bright region is Tombaugh Regio, named after Clyde Tombaugh, the American astronomer who discovered Pluto in 1930. It is a fitting name, a kind of frozen memorial on the surface of the world he found as a faint moving point almost a century ago. But the heart is not just a visual symbol. It is also one of the keys to understanding Pluto. The western side of the heart is called Sputnik Planitia, a vast basin filled mostly with nitrogen ice. This plain is smooth, bright, and strangely young-looking. In many places, it does not show the heavy cratering we might expect from an ancient surface exposed to space for billions of years. That means something has been renewing it. Something has been reshaping the surface. On a world so cold that nitrogen freezes solid, the idea of movement feels impossible at first. But Pluto does not follow Earth's rules. On Earth, nitrogen is an invisible gas, something we breathe in and out without ever noticing. On Pluto, nitrogen can lie across the ground as ice, and under the right conditions, that nitrogen ice can move slowly, almost like a glacier. Not quickly, not like water in a river, not like snow sliding down a mountain, but slowly, under its own weight, over long stretches of time. In the deep cold, Pluto's heart may be moving. That is one of the most beautiful ideas New Horizons gave us. The heart is not just a mark. It is a landscape. It is a frozen plain that may slowly churn and shift, carrying material across the surface of a world billions of miles from the sun. Imagine standing there. The sky above you would be black, even in daylight. The sun would be present, but tiny, far brighter than other stars, yet nothing like the overwhelming disk we know from Earth. It would not warm your face. It would not fill the sky with blue. It would shine as a distant white fire, casting long, faint shadows across the ice. Beneath your feet, the ground would not be ordinary snow. It would be nitrogen ice, a substance that, on Earth, belongs mostly to the air. Around you, the plain might stretch for hundreds of miles, pale and smooth, broken by strange polygonal patterns. These shapes may form because the nitrogen ice is slowly convecting, with warmer material rising from below and cooler material sinking down, like an extremely slow-motion version of boiling water. But nothing here boils in the way we know it. Nothing rushes. Nothing splashes. Everything happens in silence. Everything happens in the language of ice and time. Along the edges of Sputnik Planitia, mountains rise. But these are not mountains in the familiar earthly sense. They are likely made of water ice. On Earth, water ice melts in your hand. It cracks under weight. It floats in oceans and falls as snow. But on Pluto, water ice is so cold that it becomes strong, rigid, almost like rock. So the mountains of Pluto may be mountains of frozen water. The idea feels dreamlike. A world where water becomes stone. A world where air becomes ground. A world where the familiar materials of Earth have been rearranged into something alien by distance and cold. This is why Pluto is so fascinating. It takes things we know and turns them into something unfamiliar. Nitrogen, methane, carbon monoxide, water ice. These are not exotic substances from another universe. They are ordinary materials. But on Pluto, under Pluto's temperature, Pluto's gravity, and Pluto's faint sunlight, they behave like parts of a strange frozen geology. Methane can fall as frost. Nitrogen can flow as ice. Water can hold up mountains. And the atmosphere can appear and fade like a breath. Pluto's atmosphere is extremely thin, but it is real. It is made mostly of nitrogen, with small amounts of methane and carbon monoxide. It does not wrap the world in warmth like Earth's atmosphere. It does not carry birds, storms, or clouds in any familiar way. But it gives Pluto something remarkable, a connection between surface and sky. When Pluto moves a little closer to the Sun during its long orbit, some frozen surface material can turn directly into gas. When Pluto moves farther away, some of that atmosphere may freeze back onto the ground. In this way, Pluto's seasons are not simply changes in light. They may be changes in the very boundary between land and air. The world breathes slowly, so slowly that no human life could watch the full cycle unfold. A Plutonian year is 248 Earth years. Its seasons are measured not in months, but in generations. A winter on Pluto is not a quiet December. It is a long fading of sunlight across a world where time itself feels stretched and frozen. And yet, even there, change happens. That is what makes Pluto so different from the simple image many people once had of it. Before New Horizons, Pluto could be imagined as dead, still, and uneventful. But the close-up images told another story. A story of contrast, bright plains, dark red regions, mountains and basins, frozen gases, a thin atmosphere, and perhaps processes still shaping the surface today. One of the darker regions on Pluto is colored by complex organic molecules called tholins. These form when simple gases like methane and nitrogen are changed by sunlight and cosmic radiation. Over time, these reactions create reddish-brown material that can settle onto the surface. Tholins sound technical, but the idea is simple. Space weather changes chemistry. Light and radiation touch the gases and ices, and slowly, over immense spans of time, the surface darkens and reddens. Pluto is being painted by the outer solar system itself. The result is a world of strange colors, not the bright blue and green of Earth, not the red dust of Mars, not the golden bands of Jupiter, but pale nitrogen plains, dark reddish regions, grayish mountains of ice, and soft hazes above the horizon. It is a quiet palette, cold, subtle, beautiful in a way that feels almost lonely. And because Pluto is small, its landscapes have a different kind of scale. The gravity is weak. Mountains stand under a sky that could never hold thick weather. Ice can pile and shift in ways that would seem impossible on Earth. The horizon would curve closer. A person standing there, if such a thing were possible, would feel the world's smallness, not as insignificance, but as intimacy. Pluto is not grand like Jupiter. It is not majestic like Saturn. It is not blue and alive like Earth. Its beauty is quieter. It asks you to look longer. It does not overwhelm you at first. It reveals itself slowly, in details. A bright plain, a dark edge, a mountain ridge, a faint atmosphere, a distant moon hanging in the sky. And this is where the question returns. If Pluto has landscapes, if it has geology, if it has atmosphere, if it has seasons, if it has change, then what does it mean to say it is not a planet? The answer, of course, is that science has definitions. Pluto did not clear its orbital neighborhood. It belongs to the Kuiper Belt. It shares its distant region with many icy bodies. By the current rule, that matters. But when we look at the heart of Pluto, we are reminded that categories can be useful and incomplete at the same time. A category can organize knowledge, but it cannot always capture wonder. The heart-shaped plane does not prove that Pluto should be a planet again. It does not overturn the IAU definition. It does not erase the difference between Pluto and the 8 major planets. But it does make the debate feel different, because now Pluto is not just the object that failed a rule. It is the world with a heart, a world where frozen nitrogen may slowly move, a world where water ice can build mountains, a world where a thin atmosphere rises and falls across centuries, a world where sunlight is weak but not absent, a world that, after billions of years in the cold, still had the power to surprise us. And perhaps that is the most important thing the heart teaches us. Pluto may be small, it may be distant, it may not dominate its orbit, but it is not simple, it is not empty. It is not merely a leftover. It is a place shaped by time, chemistry, ice, gravity, and faint sunlight. A place with its own identity. A place that reminds us that the solar system is not divided neatly into important worlds and unimportant ones. Some worlds shout with sighs. Some worlds command with gravity. And some worlds wait quietly in the dark until we finally come close enough to see the heart they have been carrying all along. And beneath all of that ice, there may be something even stranger. Something hidden. Something almost impossible to imagine on a world so far from the sun. An ocean. Not an ocean like the Pacific, shining under blue skies. Not an ocean with waves, storms, tides, ships, or sunlight, but a deep, subsurface ocean, sealed beneath a crust of frozen material, kept away from the surface, buried in darkness, protected by ice. The idea sounds unlikely at first. Pluto is incredibly cold. It moves through a region where sunlight is weak and warmth is scarce. The sun, from Pluto's sky, would look like a bright star, not the blazing disk we know from Earth. The surface temperature is so low that nitrogen, methane, and carbon monoxide can freeze solid. So how could liquid water exist there? How could a world smaller than Earth's moon, drifting billions of miles from the sun, possibly hide an ocean beneath its frozen crust? And yet, the outer solar system has taught us to be careful with that question. Again and again, we have discovered that ice can hide more than it reveals. Europa, one of Jupiter's moons, is covered by a shell of ice, and beneath it may be a global ocean. Enceladus, a small moon of Saturn, sends plumes of water vapor and ice grains into space from cracks near its south pole. Ganymede, Callisto, Titan, and other icy worlds may also hold deep layers of liquid water far below their surfaces. The outer solar system is not simply a graveyard of frozen bodies. It may be an archipelago of hidden oceans. Worlds that look silent from above may be layered, complex, and active inside. Pluto may belong to that strange family. The clues are not simple. They are not as direct as geysers spraying into space. New Horizons did not fly through a plume of water from Pluto. It did not drill into the ice. It did not listen to waves beneath the crust. It only passed by once, quickly, gathering images and measurements during a brief encounter. But sometimes, a surface tells a deeper story. Pluto's landscapes suggest that the little world has experienced forces more complex than simple freezing and impact cratering. Its heart-shaped basin, Sputnik Planitia, may be especially important. This vast, bright plain appears to sit in a deep impact basin filled with nitrogen ice. Its position, its mass, and the way Pluto's body may have responded to it have led some scientists to consider whether a layer of liquid water beneath the crust could help explain what we see. If Pluto once had an ocean, or if some part of that ocean still remains today, then its surface may be only the frozen cover of a much deeper story. The thought is quiet, but powerful. Above, a world of ice. Below, perhaps, a memory of liquid water. There may also be hints in Pluto's possible cryovolcanoes. On Earth, volcanoes erupt molten rock. Lava rises from the planet's hot interior and reshapes the surface. On Pluto, if cryovolcanoes exist, they would not erupt fire. They would erupt icy mixtures. Water, ammonia, methane, or other frozen materials could behave like a kind of cold lava under the right conditions. A volcano of ice. A mountain built not by fire, but by freezing. This is one of the reasons Pluto feels so alien and so beautiful at the same time. It mirrors familiar ideas from Earth, but changes their materials. Mountains are made of ice. Plains are made of frozen gas. Possible volcanoes erupt slush instead of molten rock. The sky is black. The sunlight is faint. The seasons last for generations. And perhaps deep below, there is water. The same substance that fills Earth's oceans. The same substance that falls as rain, freezes as snow, runs through rivers, and forms clouds in our sky. On Pluto, if water exists as liquid, it would be hidden from the sun, hidden from view, hidden beneath miles of frozen crust. It would not sparkle. It would not reflect a blue atmosphere. It would not carry whales, coral reefs, or waves against a shore. But its presence would change the meaning of the world, because liquid water is one of the most important substances in planetary science. Not because water automatically means life, and not because every ocean is a living ocean, but because water allows chemistry to move. It allows materials to mix, dissolve, react, and change over time. A hidden ocean makes a world feel less like a frozen stone and more like a layered body with an inner life. Not life in the biological sense, but life in the geological sense. A slow internal story, a separation between surface and depth. A world that is not only shaped from the outside by impacts and sunlight, but also from within. Of course, we must be careful. A possible ocean is not the same as a confirmed ocean. Pluto may have had one in the past and lost it. It may still hold a deep layer of partially liquid water. or the evidence may one day be explained in another way. The truth is still waiting beneath ice, distance, and uncertainty. But that uncertainty is part of Pluto's power. It reminds us that the smallest worlds can hold the largest questions. When we ask whether Pluto should be a planet again, we often talk about rules. We talk about orbits. We talk about the Kuiper Belt. We talk about whether Pluto has cleared its neighborhood. But the possibility of an ocean asks a different kind of question. What if a world is more than its orbit? What if the inside of a world matters as much as the space around it? What if Pluto, small and distant as it is, contains layers we have barely begun to understand? There is something deeply calming about imagining Pluto this way. The surface frozen in silence, the heart-shaped plain shining faintly under a distant sun, the mountains of water ice standing in the cold, and far below, perhaps, hidden in darkness, a buried ocean rests beneath the crust. No waves reach the surface. No sound escapes into space. No eye has ever seen it. But it may be there, a secret ocean beneath a forgotten planet, or a dwarf planet, or whatever name we choose to give it. And maybe that is the point. The universe does not always reveal its richness on the surface. Sometimes, the most important things are hidden, beneath ice, beneath distance, beneath old assumptions, beneath names. Pluto teaches us to look gently, to look again, to wonder what else may be waiting under the frozen surfaces of worlds we once thought were simple. Because if Pluto can hide an ocean, then the edge of the solar system is not empty at all. It is full of quiet depths. And Pluto is not alone in that darkness. Beside it, moving through the same distant region of space, is Charon, a moon, a companion, and in some ways, the key to understanding why Pluto is so difficult to define. For a long time, Pluto seemed solitary, a faint point of light beyond Neptune, moving quietly around the sun. From Earth, it was already difficult enough to see Pluto itself. Anything smaller, anything close beside it, could easily remain hidden in the blur. But in 1978, astronomers noticed something strange. Images of Pluto did not always look perfectly round. Sometimes, on photographic plates, the little dot appeared stretched, almost as if it had a small bump attached to one side. At first, this could have been dismissed as an error, a flaw in the image, a problem with the telescope, a distortion caused by Earth's atmosphere. But the strange bump moved. It changed position over time. And slowly, the truth became clear. Pluto had a moon, a large one. It was named Charon, after the mythological ferryman who carried souls across the river into the underworld. The name fits Pluto beautifully. Pluto itself is named after the Roman god of the underworld. And here, in the darkness at the edge of the solar system, the little world had a companion named for the silent figure who moves between worlds. Even the naming feels like a story written by the sky. But Charon was more than a poetic discovery. It changed what scientists knew about Pluto. When a moon orbits a planet, it gives astronomers a way to measure mass. By watching Charon's orbit, scientists could finally understand the Pluto system more accurately, and the result was surprising. Pluto was smaller and lighter than many people had imagined. It was not a hidden giant beyond Neptune. It was not a true rival to the larger planets. It was a small, icy world, much smaller than Earth's moon in mass, moving with a companion that was unusually large compared with itself. That comparison matters. Most moons are tiny beside their planets. Earth's moon is large by the standards of the inner solar system, but Earth is still much more massive. Jupiter's moons are fascinating worlds, but Jupiter itself is overwhelmingly larger. Saturn's moons orbit a planet that completely dominates them. But Pluto and Charon are different. Charon is so large compared with Pluto that the two do not behave like a typical planet and moon system. They orbit around a shared center of mass, called a barycenter, and in the case of Pluto and Charon, that point lies outside Pluto itself, in the empty space between them. This is one reason some people have described Pluto and Charon almost like a double world. Not exactly twins, not equal in size, but bound together in a way that feels more balanced, more intimate, and more unusual than most planet-moon relationships. Imagine two dancers in a dark room, turning slowly around an invisible point between them. Neither one is truly still. Neither one simply circles the other in the way we might imagine. Instead, they move together. Pluto and Charon are locked in a gravitational dance at the edge of the solar system. And the dance is even stranger than that. Pluto and Charon are tidally locked to each other. Our moon is tidally locked to Earth, which is why we always see the same side of it from our planet. The moon turns once on its axis in the same time it takes to orbit Earth, so one face is always aimed toward us. But in the Pluto-Charon system, the locking goes both ways. Charon always shows the same face to Pluto, and Pluto always shows the same face to Charon. They stare at each other forever. If you could stand on the side of Pluto that faces Charon, you would see something extraordinary. Charon would not rise in the east, it would not cross the sky, it would not set in the west. It would simply hang there, motionless. A pale, round companion suspended above the frozen horizon, day after day, season after season, century after century. It would grow brighter and dimmer as sunlight changed, but it would never leave its place in the sky. And if you stood on the far side of Pluto, the side turned away from Charon, you would never see it at all. The great moon would be forever hidden beyond the curve of the world. This is one of the most haunting images in the solar system. A small frozen world carrying a giant moon that stays fixed over one hemisphere like a silent guardian. No sunrise, no moonset, only an eternal face-to-face stillness in the cold. And Charon, like Pluto, turned out to be more complex than expected. When New Horizons flew through the Pluto system in 2015, it did not look only at Pluto, it also looked at Charon. And Charon was not a simple gray ball. It had enormous canyons, cliffs, plains, and a dark reddish region near its north pole. Its surface told a story of stress and change. Some of Charon's canyons are immense, stretching across huge distances, deeper and longer than many familiar landscapes on Earth. They are not river canyons. No liquid water flowed under an open sky to carve them. Instead, they may be scars from internal changes long ago. One idea is that Charon may once have had an internal ocean too, a buried ocean beneath ice. Then, as Charon cooled over time, that ocean froze, and when water freezes, it expands. Slowly, powerfully, the freezing interior may have pushed outward, stretching the crust until it cracked. The surface tore open, leaving behind great chasms across the moon. If this is true, then Charon's surface is like a frozen memory of a lost ocean, a quiet record of a world that once held warmth inside, then slowly cooled in the darkness. Again, we find the same theme. The outer solar system looks still. But beneath that stillness, there are histories of movement, pressure, freezing, breaking, and transformation. Even Charon's dark red pole may be connected to Pluto. Pluto's thin atmosphere slowly escapes into space. Some of its methane may drift across the gap between the two worlds and become trapped at Charon's cold pole. There, long winters and radiation may transform it into reddish organic material, painting the moon over time. If that is true, then Pluto is not only accompanied by Charon. Pluto is changing Charon, gently, slowly, across space. The two worlds are connected not just by gravity, but by material, light, chemistry, and time. This makes the Pluto system feel less like a single dwarf planet with a moon and more like a small, distant family. Pluto, Charon, and the smaller moons, Styx, Nix, Kerberos, and Hydra, all moving together around the Sun, far beyond Neptune, in a place where sunlight is weak, but relationships are strong. And this brings us back to the question, if Pluto is not a planet, then what do we call this? A dwarf planet with a moon? A binary world? A Kuiper Belt system? A frozen pair locked in an endless stare? Science can answer some of these questions with definitions. It can describe the barycenter. It can measure the mass. It can map the surfaces. It can explain tidal locking and orbital motion. But the feeling of Pluto and Charon is harder to capture. Because together, they make Pluto seem less like an isolated object and more like a world with a sky, a horizon, a companion, and a story. Charon helped reveal Pluto's smallness, but it also revealed Pluto's richness. It showed that this distant place was not simple. It was not a lone pebble at the edge of the sun's light. It was part of a gravitational partnership so unusual that even the word moon begins to feel slightly too small. And maybe that is why Charon changed everything. It helped show why Pluto did not fit neatly into the old planetary map. But it also helped show why Pluto is so hard to dismiss. Because when we imagine Pluto now, we do not imagine only a tiny frozen ball. We imagine a heart-shaped plane under a black sky. We imagine mountains of water ice. We imagine a possible ocean beneath the crust. And above one frozen hemisphere, we imagine Charon. Still, silent, always there, watching the same side of Pluto as both worlds drift together through the long night beyond Neptune. And yet, after everything we have seen, the argument against Pluto remains. It is not an argument against its beauty. It is not an argument against its mystery. It is not an argument against the heart-shaped plane, the mountains of water ice, the possible hidden ocean, or the silent companionship of Charon. The argument against Pluto is colder than that, more technical, more careful, and in its own way, more honest. Because science cannot classify a world only by how much we love it. If it could, Pluto would have never lost its title. For many people, Pluto feels like a planet. It looks round, it has a surface, it has moons, it has an atmosphere, it has geology, it has seasons, it has history. It has a name that has lived in classrooms, books, and childhood memories for generations. But scientific categories are not meant to protect nostalgia. They are meant to describe patterns. And when astronomers looked more closely at the outer solar system, they began to see that Pluto was not alone. This is the heart of the case against Pluto. Not that Pluto is boring. Not that Pluto is unimportant, but that Pluto belongs to a much larger population. Beyond Neptune lies the Kuiper Belt, a vast and distant region filled with icy bodies. Some are small, some are irregular, some are large enough to become nearly round under their own gravity. Many move in tilted or stretched orbits. Many are ancient leftovers from the early solar system, preserved in the cold like fossils of planetary formation. Pluto is one of the greatest known members of this region, but it is still a member of this region. It is not alone in its orbital neighborhood, and that matters. When the International Astronomical Union created its modern definition of a planet in 2006, the third requirement was the one that changed Pluto's fate. A planet must have cleared the neighborhood around its orbit. This does not mean a planet has swept away every single object near it. Space is messy. Earth has near-Earth asteroids. Jupiter has Trojan asteroids sharing its path around the Sun. Even the major planets exist in a solar system filled with dust, small bodies, and gravitational leftovers. But the major planets dominate their regions. They are the central gravitational powers in their zones. Earth is not just one object among many Earth-like bodies sharing the same orbital region. Jupiter is not merely one member of a belt of Jupiter-sized worlds. Neptune is not one of dozens of similar giants traveling together around the Sun. These planets shape their neighborhoods. They gather material. They scatter material. They capture moons. They bend smaller objects into resonances. They become, over time, the rulers of their orbital space. Pluto does not do this in the same way. Pluto is large for a Kuiper Belt object, but it does not dominate the Kuiper Belt. It shares that distant frontier with many icy bodies, some of which are similar enough to Pluto that the old definition of planet began to feel unstable. This is where Eris enters the story. When Eris was discovered, it forced astronomers to confront a difficult question. Eris was distant, icy, round enough to be considered a dwarf planet, and at first it was thought it might even be larger than Pluto. If Pluto was the 9th planet, should Eris become the 10th? And if Eris became the 10th, what about Makemake? What about Haumea? What about Quaoar? What about Sedna? What about Ceres, sitting much closer to the Sun in the asteroid belt, round and complex in its own way? The solar system could have grown from 9 planets to 10, then 12, then perhaps 20 or more. Some people might welcome that. There is nothing inherently wrong with a solar system full of planets. The universe does not have to be simple for our convenience. If nature gives us 50 planets, then perhaps we should accept 50 planets. But the question is not only how many names we can memorize. The question is whether all of these objects belong to the same category. Is Jupiter the same kind of object as Pluto? Is Earth the same kind of object as Makemake? Is Neptune the same kind of object as Eris? They all orbit the Sun. Many are round, some have moons, some have geology, but their roles in the architecture of the solar system are very different. The 8 major planets are not simply large round objects. They are the main structural bodies of the solar system. They define the broad shape of the planetary system. Their gravity has carved the overall arrangement we see today. They occupy dominant positions. They are not merely inhabitants of belts. They are organizers of space. Pluto, by contrast, is better understood as part of a belt. A beautiful part, a fascinating part, a geologically rich part, but still part of a wider population of icy worlds beyond Neptune. That is why many astronomers support the current classification. It helps preserve a useful distinction between the major planets and the many smaller round bodies that share crowded zones. Without that distinction, the word planet could become so broad that it loses some of its structural meaning. If every round object orbiting the Sun is a planet, then the solar system contains many more planets than most people imagine. That may be scientifically acceptable to some, but it would also blur the difference between dominant worlds like Jupiter and smaller belt objects like Pluto. The case against Pluto is not trying to make Pluto less wonderful. It is trying to keep the map meaningful. A map must simplify, but it must simplify carefully. If it hides too much complexity, it becomes misleading. If it includes everything in the same category, it may become confusing in another way. The 2006 definition was an attempt to create order. Not perfect order, not final order, but a framework. Under that framework, Pluto became a dwarf planet. And the term dwarf planet was not meant to erase Pluto. It was meant to recognize a different kind of world, round, significant, orbiting the Sun, but not gravitationally dominant in its region. In this sense, Pluto did not fall from planet to nothing. It moved from one family to another, from the family of major planets to the family of dwarf planets. And that family is not unimportant. Ceres belongs to it. Eris belongs to it. Haumea and Makemake belong to it. And Pluto, perhaps the most famous of them all, became a gateway to understanding that the solar system has more than one kind of world. There is a quiet dignity in that. We often hear the word dwarf and think it means lesser, smaller, reduced, less worthy of attention. But in astronomy, small worlds can matter deeply. A dwarf star can shine for billions or even trillions of years. A dwarf galaxy can hold ancient stars and dark matter. A dwarf planet can preserve clues about the early solar system, carry moons, hold ice, and reveal processes we did not expect. So perhaps the case against Pluto is not as harsh as it first appears. It does not say Pluto is meaningless. It says Pluto is different. It says Pluto belongs to the Kuiper Belt, to the outer frontier, to a class of icy worlds that deserve their own attention. It says that calling Pluto a dwarf planet may not be an insult, but a more precise description of what it is and where it lives. And still, the emotional tension remains, because precision does not always satisfy wonder. When we say Pluto has not cleared its orbit, the statement is scientifically important, but it does not describe the feeling of seeing Sputnik Planitia for the first time. It does not describe the thought of Charon hanging still over a frozen horizon. It does not describe the possibility of an ocean hidden under ice. A definition can be correct and still feel incomplete. That is why this debate is so difficult. The argument against Pluto is strong. Pluto is not like the 8 major planets. It does not dominate its orbital neighborhood. It is part of a vast population of icy bodies beyond Neptune. If Pluto becomes a planet again, many other worlds may have to join it, and the solar system's old simplicity would never return. But maybe that old simplicity was never true. Maybe the solar system was always more complicated than our charts suggested. Maybe the real question is not whether the map should be simple. Maybe the real question is what kind of complexity we are willing to accept. And this is where the argument begins to turn. Because if the case against Pluto is about its orbit, its neighborhood, and its place in the structure of the solar system, the case for Pluto is about something else. It is about Pluto itself. The case for Pluto begins not with its orbit, but with its nature. Not where it lives, not what it has cleared, not how many other icy bodies move in the same distant region, but what Pluto is when we look at it as a world. Because there is another way to think about planets, a way that does not begin with dominance, a way that does not ask first whether a body has cleared its neighborhood, or whether it rules its orbital zone, or whether it fits neatly into the architecture of the solar system. Instead, it asks a simpler question. Is this object a world? Is it round because of its own gravity? Does it have layers? Does it have a surface shaped by internal and external forces? Does it have geology? Does it have change? Does it have a story written into its landscape? By that way of thinking, Pluto becomes much harder to exclude, because Pluto is not just a piece of debris. It is not an irregular shard of ice. It is not a small stone tumbling through space with no structure of its own. Pluto is round. It has enough gravity to shape itself into a sphere. It has a differentiated interior, or at least strong evidence that its materials have separated and evolved over time. It has mountains, plains, basins, glacial flows, dark reddish regions, bright nitrogen ice, and a thin atmosphere that changes with its long seasons. It has moons. It may have, or may once have had, a subsurface ocean. It has a complex relationship with Charon, so unusual that the two worlds seem almost to form a binary system. And most importantly, Pluto surprised us. That matters more than it may seem. A dead rock rarely surprises us in the same way. A simple leftover does not usually reveal a heart-shaped plain of moving ice, mountains of frozen water, atmospheric haze, and hints of deep internal history. Pluto is small. Yes. It is distant. Yes. It belongs to the Kuiper Belt. Yes. But when we look closely, we see a body that behaves like a world. This is the heart of the argument for Pluto. Maybe a planet should not be defined mainly by what it has pushed away. Maybe it should be defined by what it has become. A world does not have to be enormous to be meaningful. Earth is much smaller than Jupiter, but no one would say Earth is less of a planet because it is not a gas giant. Mercury is small, airless, and heavily cratered, but it is still a planet. Mars is less massive than Earth, colder, drier, and geologically quieter today than it once was, but it is still a planet. So why should Pluto's smallness alone make it different? The answer, of course, is that the official definition is not only about size, it is about orbital dominance. But for scientists who favor a more geophysical definition, that requirement feels strange. It defines Pluto not by Pluto itself, but by the environment around Pluto. In other words, Pluto is judged partly by its neighborhood. And that leads to an interesting thought. If Earth were somehow placed much farther out, in a crowded region filled with many icy bodies, would Earth still count as a planet by the same rule? In its current orbit, Earth dominates its neighborhood. But the idea shows why some people feel uncomfortable with defining a planet by location and surroundings, rather than by physical nature. A world does not stop being complex simply because it lives in a crowded place. A mountain does not become less real because there are other mountains nearby. An ocean does not become less deep because it is hidden beneath ice. A heart-shaped plane does not vanish because other Kuiper Belt objects share the same frontier. Pluto is Pluto, wherever it lives. That is why some planetary scientists argue that the word planet should describe a type of body, not a type of orbital achievement. Under that view, any round world shaped by its own gravity and complex enough to have geology could be considered a planet. That would include Pluto. But it would also include many other objects: Ceres, Eris, Haumea, Makemake, perhaps even large moons like Europa, Ganymede, Titan, and our own moon, depending on how broad the definition becomes. And this is where the debate becomes fascinating, because the argument for Pluto does not simply restore the old 9-planet solar system. It opens the door to a much larger one, a solar system not of 8 planets or 9 planets, but of many worlds. Major planets, dwarf planets, ocean moons, icy bodies, rocky worlds, places that do not fit neatly into the categories we learned as children. In that version of the solar system, Pluto does not return alone. It returns as part of a larger transformation in how we think. We no longer imagine the solar system as a simple family of a few important planets surrounded by lesser debris. We imagine it as a rich collection of worlds, each with its own history, its own structure, its own mysteries. This may be less tidy, but it may be more true to nature. The universe is not always tidy. Nature does not arrange itself for easy memorization. It creates gradients, exceptions, overlaps, and borderlands. There are objects between stars and planets. There are moons larger than planets. There are dwarf planets with moons of their own. There are icy worlds with oceans beneath their crusts. There are asteroids that look like miniature planets, and planets that look like failed stars. Pluto lives in one of these borderlands. That may be why it feels so important. It challenges the boundary. It asks where the word planet should end. It asks whether a category should be based on the role an object plays in the solar system or the kind of body the object is. The official definition focuses on role. Pluto does not dominate its orbit. The geophysical argument focuses on nature. Pluto is a complex round world. Both sides are looking at something real. That is why this debate has lasted so long. If one side were obviously wrong, the question would have faded away years ago. But Pluto remains difficult because it belongs to more than one story. It is both a Kuiper Belt object and a world, both a dwarf planet and, to many, planet-like in every meaningful physical sense, both a member of a distant icy population and a place with landscapes that seem to ask for the same respect we give to larger worlds. And perhaps respect is part of this. Not scientific sentimentality, but scientific attention. Calling Pluto a planet again would not make it more complex. It would not change its surface. It would not thicken its atmosphere. It would not warm its hidden ocean, if one exists. It would not move Pluto out of the Kuiper Belt. But names influence attention. They shape what the public remembers. They shape what children imagine. They shape what missions are proposed, what questions are asked, and what worlds feel worthy of exploration. When Pluto was called the ninth planet, it occupied a clear place in the public mind. Everyone knew it. Everyone learned it. Everyone imagined it waiting at the edge. When Pluto became a dwarf planet, some people felt that its importance had been reduced, even if scientists did not intend that. The danger is not that Pluto truly becomes less interesting. The danger is that people stop looking closely. And Pluto deserves close attention. Not because it is famous, not because it was once on school posters, but because it is scientifically extraordinary. It is one of the best windows we have into the Kuiper Belt. It shows us what small icy worlds can become. It reveals that the outer solar system is not a frozen wasteland, but a realm of active surfaces, complex chemistry, possible oceans, and unexpected beauty. If Pluto can be this rich, what about the other distant worlds? What about Eris, far away in the cold? What about Makemake and Haumea? What about Sedna, moving on an extremely distant orbit that carries it into regions we barely understand? What else is waiting out there, too faint for us to see clearly? The case for Pluto is also a case for curiosity. It says we should not let a simple map make the outer solar system feel unimportant. It says we should not confuse dominance with wonder. It says that a world can be small, distant, and surrounded by others, and still be worthy of being understood on its own terms. And maybe this is why Pluto has such a strong hold on the human imagination. It is not only because we miss the old solar system. It is because Pluto represents the idea that small things can matter, that distant places can be rich, that what we once dismissed can become beautiful when we finally see it clearly. There is a kind of quiet justice in that. For decades, Pluto was imagined as the last planet. Then it became the first famous dwarf planet. Perhaps in the future it may become something else again, not because the universe changed, but because our language changed to better match what we have learned. This is not weakness in science. It is one of science's greatest strengths. Science can revise itself. It can correct old assumptions. It can make sharper categories, and then question those categories when new evidence arrives. The reclassification of Pluto was part of that process. The continuing debate is part of it too. To argue for Pluto is not necessarily to reject science. It can also be a way of asking science to keep refining its words, to make sure its definitions do not become cages, to make sure the richness of a world is not lost behind a technical boundary. Because Pluto is rich. It is small, but not simple. Cold, but not dead. Distant, but not irrelevant. It moves through the Kuiper Belt with a frozen heart, a thin atmosphere, mountains of ice, and a companion that never leaves its sky. Maybe it did not clear its neighborhood. But it did something else. It cleared a place in the human imagination. And perhaps that is why, even after all these years, people still ask the question. Not because the answer is easy, but because Pluto makes the question beautiful.